I'm going to talk about some of the internals of monitoring that I've been tidying up in the last year or so. So most people, when they use Parsl monitoring, there's a user approach, which is you configure monitoring hub, you run your workflow. What comes out of that is an SQLite database with your juicy monitoring info, and maybe you talk to that with SQL, maybe you use Parsl Visualize or whatever. And that's the bit I'm not going to talk about. What I want to talk about is how stuff gets into that database. So throughout all the distributed bits of Parsl, there's basically an ability for most components to generate a monitoring message. There are various types. They all get sent down this blue arrow, which I'll go into more details of in a minute, to the database manager process. That's the pink thing over there at the left. And that's the only thing that deals with the database. So everything else monitoring in Parsl is monitoring messages. Things like workflow info is starting and stopping the workflow, task info, tasks, fairly obvious stuff. If you've used the database directly, you'll recognize the format of most of these messages anyway. So going down one more layer there, what happens is that there's a multi-processing queue in Parsl, and any process that's running in the core submit side processing group can put messages into that queue, and it pops out at the database manager. So that's the data flow kernel for workflow and task information, and the block scaling code is also running. They're both running in the submit process, so they have access to this queue, which is just Python multi-processing stuff. Then other processes that are running elsewhere can't do that. So the HTEX interchange, for example, wants to make a node info message every time a worker pool registers a new node, and that gets passed over ZMQ, which is the standard protocol that most of Parsl uses for stuff. And that goes to this pink process at the top, a ZMQ receiver, which is running in the submit side group. And all that does is gateway ZMQ messages into this queue and onwards to the DB manager. Another thing that happens is tasks. They may be running the far side of your cluster on a worker node, and they run, if you have monitoring turned on, they have a little wrap around them, which probes for resource usage and things like that. And that traditionally in the original monitoring sends things over UDP to similar UDP receiver process, which gateways UDP messages into the multi-processing queue. Maybe you're seeing a bit of a theme here. UDP, the U is for unreliable, of course. If you want reliable monitoring messaging, there's another option called the file system radio, and that does its network traffic using a shared file system. Much more heavyweight, but it actually delivers the messages properly. But that's the same setup. So that making that configurable between these two things is something that I've worked on in the last year, and it's pluggable because I like plugins. So you can plug your own code in there if you want to experiment with different things there as well. Two of the executors in Parsl have their own custom radio types for doing this because they're able to do something special. So if you're using the local executor, which is where join apps run, anything on a thread pool executor, that's running on the submit process anyway. So we don't need any receiver gatewaying or anything like that. We can just write straight into the queue, and that's extremely lightweight. So that's this bottom blue blob. And then if you're using the high throughput executor, we've got this nice result path already for sending results back, your task results. And there's a HTEX method for sending results back, sending monitoring messages back over the result path back to the interchange. The interchange already has this ZMQ path for sending node messages. And so we don't need to establish anything new. We can use the existing channels as long as the arrows all join up and get us to the multi-processing queue and onwards to the DB manager. So that's a deliberately fast overview of the messaging paths, right? And the key idea is you have messages, there aren't any other shared objects, and you flow towards this multi-processing queue and then onwards to the database. And originally, when I did this work, I was imagining that the key thing that people would hack on and people would want to experiment with was this stuff at the top, getting messages from remote tasks and getting them gatewayed into the submit side.
Permanently.
So instead of using UDP or file system, maybe you've got something cool to do. And people have tried to do that before, and it's just turned out to be practically really awkward. But I also realized when I was doing that, there's two other places that I've also talked about doing things with people in Parsl and Globus Compute before that kind of fit in here. Now this is a bit tidier. One is on the left, you could replace that database manager with something completely different. Maybe if you had a workflow system that's sitting around Parsl and it would like to see these monitoring messages directly rather than use the Parsl database, you can chop off that DB manager, listen to the multi-processing queue yourself. The other thing, this task wrapper on tasks on worker nodes turns out to be pretty heavyweight. I've definitely talked with a couple of people about making a per node wrapper here. That's fine. You can cut that out. And as long as you're making those resource messages that look right, the rest of the monitoring system also doesn't care what's happening there. So the end goal of this is I want you to be able to plug your own stuff in here and fiddle with it more easily. That's why I did this work. And these three green arrows are the three places that you could do that. And that's my talk.